Hi everyone, welcome to today's Harnessing the Power of Ci64 in Packaging webinar. Today we have X-Rite Solution Architect Bob Binder presenting. I'm Amanda Carter, one of X-Rite's North American Marketing Managers, and I will be moderating today's webinar. A few things to go over before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. During the webinar, if you have any questions, please use the questions function on the GoToWebinar panel. We'll have some time at the end to answer a few questions, and if we don't get to yours, we'll have someone follow up with you. There will be a couple poll questions throughout the presentation for you to answer, so be on the lookout for ways to participate. And finally, this webinar will be recorded, and you will receive a link so you can review the webinar at your convenience. I will now turn it over to Bob.
Hello, everybody. And as Amanda said, my name is Bob Binder. I'm a solution architect here at X-Rite. And today what we're going to talk about is the Ci64, which is an X-Rite spherical instrument. And typically when we're producing printing or packaging, what we're using is a single angle or a 45-0-degree instrument. But there's cases where the spherical device is more applicable to our needs. And so that's what we're going to take a look at today, is this particular device and where it's oftentimes useful to use this in our workflow. There's a couple of applications for this particular device, and you can see on screen a couple of images here that we've included. And one of the challenges that we face when producing packaging is the variety of substrates that we're asked to print on. One of those substrate types that's very challenging is a reflective material. And when I say challenging, it's probably has its challenges printing on it. But in the case of measurement, this can be difficult to measure with a single angle instrument. And I'll talk in just a couple minutes about why that is. But with reflective surfaces, when we're printing transparent ink directly onto metal or onto foil substrates or metallized surfaces, things like metallized paper or metallized film, we get a high degree of reflectivity off of those surfaces. And it's why brands like to use these for packaging, because they're very eye-catching, they're very appealing to the consumer, but they can be difficult to measure if you don't have the right type of spectrophotometer. The other case that we run into quite often is if we're asked to print on materials that have a texture to them, things like textiles or foam drinking cups. If you look at the surface of those, it's actually quite textured. It's not a perfectly flat surface. And this is something that a traditional 45-0 spectrophotometer can find challenging as well. So one of the ways that we have to measure this in a more accurate way is to use a spherical device. Now, there's a lot of these different applications for these type of materials. There's cans, bottle caps, textiles, or anything that has a mirror-like finish where the light reflects off at a very specific angle. These are commonly used by brands, and we're seeing their use happening more and more often. And another consideration with these, one of the challenges for us as converters is that these are oftentimes very expensive materials as well. And so therefore, if we waste any time or material trying to get to color or trying to get consistent color, that could become very expensive to us. So it's important that we do have the proper measurement instrument for these types of materials. Now, we do have in this presentation two different polls. So this is the first poll, and so Amanda is going to be putting this up here. But what we're asking in this case is, if you currently use color measurement instruments, and then if you do, if you know what type of instrument that is. So we'll give you guys just a minute or two to answer this question, and then we'll revert back to the presentation. Okay, do you think that's enough time, Amanda?
I think we're good to move forward. Thanks, Bob.
Okay. Is it back on my, there we go, perfect. Okay, so let me explain why we have difficulty using a traditional single angle, or as it's sometimes called 45-0 geometry instrument when measuring these type of substrates. And the single angle is the type of instrument that's typically used in print and packaging. And the way this instrument works, there's a lamp in the instrument that illuminates the surface that we're measuring. And as you can see here, I've kind of illustrated a magenta ink being printed over a metallized surface, which is very reflective. And the optics in this instrument are positioned directly over the top of the material that's being measured. And that's why it's actually called a 45-0, is those are angles following the path of the light. The difficulty when we're measuring something that is very reflective, most of the light reflects off at 45 degrees, the opposite of our lamp. And so what I'm illustrating in this drawing here is that very little reflected light, if any, actually gets reflected back up to our optics. And so the instrument is getting a very, very small signal, with most of the reflected light being lost. And so if we're measuring something that's on a truly reflective surface, this is what's happening. Most of the reflected light is being missed by the instrument. Also, if we do measure something that has a textured surface, and if we think of something like a foam drinking cup, there's little beads there, and because it's not a nice flat surface, the light that's reflecting from that light may be hitting the surface of those beads at different areas and causing the light to reflect off or scatter in different directions. So if we were to move the instrument and take different readings with a single angle instrument, we're likely to get a lot of variation introduced because of the instrument. So what do we do about this? Well, we have a different type of instrument geometry called a spherical device. You may sometimes hear this referred to as a D8, and the D8 is because the D stands for diffuse, and 8 refers to an angle of measurement, just like in the 45-0. 8 is referring to the angle that we're measuring at. Now, in this instrument type, and I've actually got two different illustrations here showing this geometry, but what happens is we're actually measuring inside of a sphere, or if you could picture like a ball, like a basketball, if we were actually cut a slice off of it and place that slice over the object we're measuring, we're then reflecting the light inside that sphere, and that's what we're measuring. So the lamp in this instrument design is on the side of this sphere. And if you notice, there's a little baffle that I've got showing right below the lamp, and that just keeps light from shining directly onto the surface that we're measuring. The inside of this sphere is very reflective, and it's a white neutral surface. So all of the light that's emitting from that lamp, it starts bouncing around inside of this sphere. And so what happens is we illuminate the object that we're measuring from every angle. Okay, the light's just bouncing around and striking that surface. Now the optics of the instrument, if you look at the illustration on the left, is positioned 8 degrees off center, and there's an opening in this sphere where our optics are. And that arrow you see leaving the sphere, that's what that's illustrating, is that's the light that is being measured by the device. And since this light reflected off of the object is scattering around inside of the sphere, we're able to capture all of that light. So we don't have any light reflecting away from our optics like we do with the single angle design. Now the illustration on the left, you may have heard a term spin or spec, or specular included or specular excluded. That's what those actually stand for. The image on the left is specular included. So if you can picture, just like in the 45-degree instrument, we illuminated the object at 45 degrees, and 45 degrees at the opposite angle is where most of our light was reflected. Because we're now sampling this measurement at 8 degrees, 8 degrees the opposite direction would be a direct reflection from where our optics are positioned. When we take a specular included reading, we're including that reflected light because it just is bouncing around inside of the sphere. And if we're just taking a single reading in packaging, this is typically the mode that's used, is specular included. If you look at the image on the right, this is something called specular excluded. And the spherical device, the Ci64, has an extra option that we have a small opening in the sphere that we can open. It's a little port that can open and close. And if we open that port, that allows that light at the opposite angle of our optics to escape from the sphere, called a specular excluded reading. And the fact that we can take both of these with the Ci64, and unlike anybody else, we can take specular included and specular excluded both in the same reading. That allows us to do a couple of things. First of all, it allows us to get that accurate, consistent reading that I mentioned before, and that can actually be done with just the specular included. But having both specular included and specular excluded, for those of you printing directly on metal, like beverage cans or tin boxes, there's a lot of little tin boxes, like for throat lozenges, those kinds of things, where we print directly onto metal itself. We have a couple of metrics. We have a correlated gloss metric that simulates a reading from a gloss meter. We're able to calculate that, having specular included and specular excluded. And then there's also a metric known as the metallic brilliance ratio, which is commonly used for aluminum beverage cans. And by having both specular included and excluded data, we're able to do that calculation as well. So with that, let me move on to the next slide. And I want to give you a couple of illustrations, actual readings taken with both a single angle device and a spherical device, because it's thing for me to sit here and tell you what happens, but I think it's much better if I can actually show you what happens. So in this first slide, I took a reading, and this is actually, if you look in the lower right-hand corner, this is actually a photograph. This is a tag, a gift tag, actually off of a gift box, and this was printed on metallized paper, and it's a red transparent ink over the top of this metallized paper, which of course gives it a very reflective appearance. If you look at the screen grab on the left-hand side of the screen, this is a measurement that I took of this tag using an X-Rite Exact, which is a 45-0 instrument. I've got two different views that I captured here of this reading. The leftmost image is a specular curve of this reading. And if you're familiar with this, this is a graph showing how the light is reflected throughout the visible spectrum. The black line that you see right at the very bottom of this graph that just goes up a tiny bit on the right-hand side from 600 to 700 nanometers is the spectral curve for this reading. You can see it's reflecting a little bit of light, or it's capturing a little bit of reflected light in that region from 600 to 700, which is red wavelengths of light. The black square that you see, that's a visual representation in the software of what the instrument saw. And as you can see, basically, when I measured this red surface, the instrument saw black. And the reason for that is so much of the reflected light is reflected away from the instrument optics. It just wasn't seeing any light at all. So it thought that I was measuring something black. The right-hand side of the screen is basically a screenshot showing the same data, but this is data from a Ci64. So now if you look at the spectral curve, this is what we expect from a red, right? We're reflecting a little bit of light from 400 to 600 nanometers, but then as we approach 600 nanometers, the amount of reflectance increases greatly. So this is a typical curve for a red color. And then of course the visual match, you can see there that it is red. Now, of course, this is a representation in a flat color in my software, so it's just showing the pure color. It doesn't have the same reflectivity as the sample. So, I mean, it doesn't look just like that, but the color that we're measuring is much, much more accurate. I also included the LAB values, and as you can see, the image on the left with the 0.45, our L value is 2.08, which is probably darker than any black that you measured. But again, it's because all the light is reflecting away from the optics. This is another example, doing kind of the same thing, measuring a sample with both an Exact and a Ci64. But in this case, what I've measured here is a brushed aluminum. And this is actually aluminum, such as might be used for chewing tobacco container. So these are actually sheets of aluminum that are printed. And this is another good example because I actually have two different things going on in this sample. We have the high degree of reflectivity, because we're printing transparent ink over, in this case, an actual metal sheet. But we also are introducing some texture because this is a brushed aluminum, so you can see kind of the effect of that brushing, little horizontal lines going horizontal on here. And so not only do we have a lot of the light reflecting away from the optics, but in this case, that texture that we're introducing is going to cause the single angle instrument to have some inconsistency in the reading because the light is not reflecting consistently. In some cases, there's going to be some light reflecting back to the optics. So if you look at the data on the left-hand side, you can see if you look at the delta E column, and I'm looking at the data that's mostly red, not the data at the top, but these are our sample readings, and you can see there's a lot of variation, as much as almost 5 delta E variation as we move around from one sample to another. So not only do we get the inaccuracy of the readings, but that texture causes us to have variations in the reading. Whereas if you look at the data which is actually in the center of the screen, but the right set of data, this is from the Ci64, and in this case, not only are we measuring an accurate green color, but our readings are very, very consistent. So in this case, we have both of those situations going on. So we can use the Ci64 for a lot of different materials, and this is kind of what we're showing at this screen here. It's good for metallic surfaces, for very reflective surfaces, and for textured surfaces. And use of the Ci64 in this case will help us get more accurate information. It helps us get more consistent data, and we also support Net Profiler with the Ci64, as we do with the Exact, but this will help us to assure consistency among all of our devices, and it helps us to create a good trail, a data trail, so that we have reliable data over time. Now, the Ci64 is also supported by all of the major X-Rite software products. What we're showing on this screen is the ColorCert product, which is used by a lot of brands because it has scorecard server reporting that the brands like. It's also something that's very useful for the converters to track their production over time. And we also support Color IQC software, which is another software that's commonly used in packaging. And Color IQC has the advantage today that it does support simultaneously spin and spec readings. So it does have the ability to calculate correlated gloss as well as metallic brilliance ratio, which again, as I mentioned, for the beverage can industry is very important. Today, ColorCert will allow you to use the Ci64. It does not allow, and this is today, it does not allow us to capture both specular included and specular excluded. You can do one or the other, but as of today, it doesn't do both at the same time. This will be incorporated into version 4, which is slated to come out later this year. So if that's something that's important to you, please know that we will have that coming up very shortly. And also, when we look at the entire workflow, Ci64 is also supported in our ink formulation software, which is commonly known as IFS. And this will allow you to get accurate ink matches the first time. Typically, we measure our sample. The software is able to give us a formulation for that and gets us to color in our ink lab very, very quickly. It's also really useful for working off waste ink because we can measure a sample of our waste ink and we can then use that to tip it over for another color on an upcoming job, or we can use that as a component in some other ink. So IFS is also a product that typically saves us a lot of time and money in our production. And also Pantone Live, I'd be remiss to mention that. Pantone Live is a digital version of all of the Pantone colors, not just the master libraries that we have in our formula guides, but it also includes dependent libraries, which are databases of colors matched as close as possible to the formula guide in a number of different scenarios with different print processes, different substrates, and different ink systems. And both IFS, ColorCert, and IQC, all three have support for Pantone Live as well. So that's another consideration for your workflow. Just a quick slide here about some of the specifications for the Ci64. It's available in two different aperture configurations. The model that's going to be most popular in print operations is going to be the model that has both a 4mm and an 8mm aperture. And there's a switch on the bottom of the instrument that allows you to switch back and forth between the 4mm and the 8mm. And the reason that I said this is going to be the most popular is that when we're taking measurements in a press room, real estate is generally a big concern. You know, do we have a patch big enough that we can measure with the device? And the Ci64 that has the 4 and the 8mm allows us to measure a patch that's much smaller than most spherical devices. The other model has 4mm aperture, which is too large for most print applications, but if you have an ink lab and you're doing ink formulation, you might want that larger aperture for the ink lab. So there's two different configurations there. And again, one model has both a 4 and an 8mm aperture, which are switchable by just turning a switch, and the second instrument that has the larger, the 14mm aperture. We have full support for Net Profiler, and Net Profiler is a program that allows you to measure a whole series of tiles that are included with the kit, and it takes the data that the instrument is measuring, it compares it to the master data for this tile set, and then if necessary is able to make corrections to the data coming from the instrument. So if we have a large pool of instruments, we have confidence that we're getting the same data, the same readings from all of our instruments. The Ci64 has something called graphical job function, which is kind of a cool feature if you're using the instrument standalone. What this feature allows you to do is to display instructions on the screen of the instrument. So, for example, if we needed some of our workers to go out and just do random samples in our warehouse, we could create a graphical job for that function and prompt them to take specific readings of specific products and prompt them to do that through the screen, and they would walk through this function. We can actually display images. So if, for example, there's a specific location on a product that we want the operator to take a reading from, we can actually display that on screen using this function. The repeatability of these instruments is actually pretty amazing. 0.04 delta E. That's like pretty incredible, actually. We're talking 0.04 of a delta E for the repeatability. And then we also have Bluetooth as an option, which is kind of nice because it gets rid of the cable for us. And then the instruments do run off of a battery. So with the Bluetooth and the battery, we don't have any cables at all, which really makes it nice. The Bluetooth is not available in all countries. There are some countries where there's restrictions on the Bluetooth, but in most of the world, that is an option. So one caveat there. Which brings us to our last polling question. And actually, this will be basically the end of the presentation as well. But if you could just take another moment and let us know your level of interest. And if you're not interested, then we won't bother you. But we'll just take a minute here. Okay, Amanda, you think that's good?
Yeah, that was a full minute of silence for everybody
Okay.
to endure.
Right. All right. So this is my last slide. So basically, I've just got contact information if you want to get in touch with us. And with that, I can just go ahead and open it up for questions. So I don't know if do we have anything in the chat, Amanda, for questions?
We have gotten a couple questions, and
Good.
this is where us being virtual and not in the same room, I can read them off. And
Yeah,
if it's something that, just let me know, and we'll say, like, no, we'll take this one offline to discuss and move on to the next one. So our first question is dealing with which device or devices would we recommend for a folding carton printer who in the same job have standard inks like process and spot, as well as metallic inks like silver and gold?
Okay. All right. Yeah, that's a great question. And if they're actually metallic inks, we see this quite often. And typically a metallic ink, now I want to be careful here because the technology continues to improve all the time. But if it's a metallic ink rather than a transparent ink actually going onto a metallized surface, very often we're able to get accurate readings with a single angle or an exact style instrument. So what's typically done in those cases is we'll use the exact for both, for the standard inks and for metallic inks. Now, if a customer has specific questions about some specific samples that they have questions about, we can always we'd be happy to look at those for them. So they could get in touch with us, and if they want to send us some samples, we could measure those samples with both geometries and let them see what the difference would actually be. But oftentimes with metallic inks, the single angle instrument is still sufficient.
All right, great. And then I think we'll have one more here.
Okay.
Does the Ci64 capture the total reflectance? They're currently able to obtain this measurement from their benchtop unit, but have some interest in a handheld Ci64.
Okay, so yeah, that's an excellent question as well, and the answer is yes. It does. It has both specular included and excluded, as does your benchtop, and so you could expect to have very, very tight correlation between the two. It's basically measuring the same. The one thing that we don't have handheld unit that's probably not applicable anyhow in this case, but a benchtop unit has the ability to do transmission readings where we actually pass light through a sample, and that's done by placing the sample inside the benchtop instrument. Generally, that's done for plastics, if someone's molding translucent or transparent plastics. So just be aware of that. It does not allow transmission readings, but yeah, as far as the total reflectance, the answer is yes.
Great. Is this the only spherical model, or are there other X-Rite models on the market?
As far as handhelds, this is it. There is now we talked specifically about the Ci64 today. There's also a Ci62 which has less features, and then there's a Ci60 which doesn't communicate to software, so that's generally not applicable. But then we do have, as was just mentioned in the last question, we do have a lot of benchtop models as well that are of the spherical geometry. But in the handheld market, like we typically use in the press room, this is the device.
Perfect. I think we can take maybe one more, two more. What do you feel?
Sure. Yeah, no problem.
Okay. Quick one. Someone asked, is an i1 Pro 2 a spherical device?
No, the i1 Pro 2 is a single angle.
And then for our last one, can measuring be automated or turned into a strip or like a color bar reader with this device?
Okay. Sure. So I think what they're asking here is, can it be used in the scanning mode, sort of like the exact? And unfortunately, no. This doesn't have a scan mode, so this is strictly for spot reading.
Okay, and then one more, if we have time. I don't know how much detail we would need to go into for this one. Can you please explain the Ci64 UV application?
Okay, sure. So the Ci64 is designed for measuring products that have a high level of optical brightener or materials that components that fluoresce. The difference between the Ci64 and the Ci64 UV is the Ci64 has a tungsten lamp in it, which will have some amount of UV light in it. In the Ci64 UV model, we add a separate UV lamp in it. So if you are measuring objects that have a lot of fluorescence, or where the level of fluorescence is very critical, then the Ci64 UV model can come into play. And I tend to think of things like military uniforms, which it's critical to have no UV light in the material, no UV components that will reflect, because it makes them much easier to be picked up by night vision goggles and things like that. For that type of thing, the UV version can become very important, but that's the purpose of the UV model, is for those cases where UV is critical, and we need to have extra care in that region.
Awesome. Well, that was the last question that we have time for. So this marks the end of our webinar. Thank you, Bob, for an awesome presentation. And thank you, everyone, for joining. If we weren't able to get to your question, we will follow up. Don't worry. And you will also receive an email with a link to the recording of the webinar. So thanks again, everyone, for joining, and enjoy the rest of your day. Thank you.